Hello, my name is Cameron Ship,
My name is Amber Riggs.
And my name is Bianca Allen.
and this is our presentation over a simulation of a valve assembly process. Project outline. Our team analyzed the current process at a local manufacturing company to identify alternatives to improve the valve assembly process. Our goal is to recognize the bottlenecks of the system, which will allow us to make recommendations for the future. Our entity is the valve parts. Our resources include Assembler 1, Assembler 2, and Assembler 3, and a set of operators, which are made up of Operator 1, Operator 2, and Operator 3.
Flow chart of the system. Where we start, there's a forklift operator that delivers valve cases and wedges to the conveyor belt. From there, Assembler 1 places the wedge nut into the wedge, then sets it on the conveyor. Assembler 2 places the gasket, installs bonnet and the stem assembly. The assembler number 3 places and tightens bolts on the valve. From there, it is placed and left on the conveyor belt for the tester to remove and complete the testing. And it ends after the testing. The valve is removed and placed onto the conveyor to go to the platform for packaging.
The construction of our arena model begins with a create module where the first entity is created for our system. The entity then goes through the bin station and the route to the system. After it's at assembly 1 station, it's seized by a seize module and sent to a separate module where the first entity is then duplicated. The original entity loops back to the bin station and the route to system, and the duplicate entity moves on to the delay for assembly 1 process, and then the resource and entity are released at the release module. After this, it moves on to assembly 2 and assembly 3, and then the testing process. We use stations and routes at the end of our model for animation purposes. So the entity then goes through the testing station and the testing route and to the exit station, where the entity then exits to the packaging platform.
Here is our animation. You can see that through this process, the parts move from Assembler 1 to Assembler 2, then to Assembler 3, and on to the testing area. From the testing area, you can see that it moves on to packaging. The observed bottleneck that we found was that the process begins backing up at the testing stations. By the end of a 10-hour shift, there are 1,558 valves waiting in the testing queue.
To analyze our data, we decided to use OpQuest. We wanted to optimize our information based off 2 objectives. The first one being minimizing the number waiting in the queue, and the second, maximizing our output. So as you can see from the screenshots or the images on the screen, we found out that the best way to optimize the situation was to have 2 extra duplicates of operator 1, since he had the fastest operating time, and then keep 1 operator 2 and 1 operator 3.
We have concluded that the best option for the company is to add 2 more operators to the system that are identical to operator 1. By duplicating operator number 1 2 more times, average number out would increase. It did increase from 358 to 502 valves, and the average number waiting in testing queue reduced from 775 to 703 valves.